So here we are. We're going to begin with an overview of our Miller welding devices. So when you guys look up here at the spools of wire and you see copper, there, then you know that's a MIG welder, okay? You know that's a MIG welder. But then as you go down here, this wire does not look copper. So I want you to instantly know these are Flux Core machines, okay? Flux Core wire. So make sure you know that if you see the copper coated steel spools, that's MIG. If you don't, they look kind of silver. These are Flux Core. Now, are these Flux Core machines, are these dual shield or are they inner shield, or what we call maybe self shield or Flux Core wire? Well, when you look in the booth and you don't see a regulator, or I'm sorry, a flow meter, there's no gas flow meter, you can pretty much be assured that that's inner shield. Now, on this booth right here, we got, you can see we got the Flux Core wire, and you're looking right at a flow meter. So that would definitely tell you that this is dual shield Flux Core. So the first thing is to kind of know that, like, what's like in the booth. Now, if you look at the spool, you can also tell what it is. This is a Lincoln Ultra Core .045, and if you Google that and you did a tiny bit of research, you would tell that it's a dual shield wire. And then just so you guys know, we have it set up to where let me get a better angle here. We do have some booths here that have the thicker Flux Core wire. So we have 4 booths that have the 068 stuff you do like I-beams with, like the stuff they welded SDA buildings with. All right. So I guess my first thing now is I want you guys to visually know what the wire looks like and what is the booth. All right. So we have this Miller machine. It's an XMT 350. CC stands for constant current / constant voltage. So what that means is that this, we can put this on stick and it'll be doing constant current. We could go over to MIG and it'll be doing constant voltage. And we can even hook up TIG devices to this. So this knob here lets you have different types of power except for alternating current. And it does some other really cool things too. So with this machine, you have to buy a wire feeder. So the wire feeder is this thing. So that's the wire feeder. And this is basically our power source. Now, that gives us more options. So when I bought these machines, that gives a lot of options for us. Now, if you compare that to this machine right here. This is a Miller Matic 252. Well, this thing is made for wire feed only. So you open up the hood here, and obviously this thing is meant to put in a Flux Core or a MIG wire. This thing can't do TIG. It can't do stick. So this is more of a just, you know, it's meant for one thing. So the reason why we have these devices is it gives us more options. So how does it work? Well, let's go through that. First, I'm just going to unplug everything. All right, so this machine has a on-off button. I like to have it off when I'm putting things in there. But let's just say if you wanted to stick weld, okay? Most of our electrodes are electrodes positive, direct current electrode positive. So there is a little keyed connector right here, you can see. So that goes at the 12 o'clock position. And then I twist it clockwise to lock it in. Then we would get an electrode for stick welding, electrode holder. We have two different styles, but this guy would go into the positive. I got the key connector. This would go 12 o'clock position, clockwise. And then at that point, we have our ground connector. It will go on our metal table or our project or wherever, not painted metal. And we turn this on and we put it at stick. Turn on the machine. And I would just say, here's our voltage. You know, put it somewhere between like 100 and 125. So somewhere between 100 and 125. This knob called arc control is really for stick welding. And the reason why arc control is pretty awesome is because, let me get a piece of metal here. Let's see. So this is my electrode here, right? And you want to keep the electrode about 1/8 of an inch to 1/4 inch off the metal. If you get it too close, your electrode sticks to the metal and it's frozen and everything stops welding. Game over. So what arc control does is, as the electrode gets closer to the metal, it automatically increases the amperage. So if I'm at 123, it'll bump this up, trying to not have the electrode stick. So we tend to set this at 30, but that's what it's for. It can help you when you do get really, really close. Without arc control, your electrode could stick, stop welding, game over. But with arc control, it might help you to not get stuck. And there's some other things too, but that's one thing. So for stick welding, that's really it. I got this guy in the positive lug, this in the negative. Now, how do students mess this up? If you do not take this knob out, it will not work right. Don't know why, but this is from our wire feeder for MIG welding. If this is plugged in here, it doesn't operate correctly. I don't think it should be that way, but that's the way they engineered it. So this thing has to come out. Has to come out. And then, yeah, you just basically, you get your metal plate and get yourself about a dozen of these electrodes. Watch another video for like the process, but I'm mainly going over how to set up the machine today. Does anyone have a question about stick welding? Okay, next thing.
Oh, When would you use it?
When you want to weld things that are not aluminum.
Cool. Thank you.
Yeah, yeah. It was the most popular welding method 30 years ago and beyond, but with the inventions of Flux Core, it's kind of fallen to not be the front runner. All right, here we go. So let's say now that you want to do some Flux Core or some MIG welding. Okay, this wire feeder, it has two cables that come off of it. So from the back of the machine, if you follow the two cables, this is what they look like. I got two of these guys here. Okay. Now, as far as this cable goes here, it's delicate, be careful, but there's a little keyed connector here, a little slit in the plastic. You can see that little thing. Put that slit at the 12 o'clock position. So 12 o'clock position, and then just go ahead and turn it clockwise. All right. Don't ever pull the plug by the cable, you know, always grip this. So that's first and foremost. Now, if you're going to MIG weld, what that means is that you are going to be putting, you want the gun to be positive. This is also true for Flux Core dual shield wire. So for Flux Core dual shield wire and for MIG welding, you want to put this in the positive position. Okay, clockwise. Ground clamp is going to go in the negative. Then you open the door and you put it on MIG. Now, if you're going to Flux Core, it's got to think of it as MIG. It's just different wire. So you put the knob at MIG, whether you're doing Flux Core or MIG. And you turn it on. And now, instead of having amperage, you're going to be having voltage. And I would say that for voltage, this is where it gets a little confusing. So this knob here does nothing. It's deactivated, it does nothing. But up here, it says voltage right here. When I move this knob, the digital readout moves. See this? So you have to kind of have your right hand up on the knob, and then you look down here as you move the knob. So I would say you're going to be somewhere between, I would say 17 volts and 23 volts, depending on if you're doing thicker or thinner stuff. That's just the average for my class. Of course, you can go less than 17 or more than 23. I'm just telling you what the average student is doing in here. They're doing 16 gauge metal to like 1/4 inch. All right, so that's how this first knob works right here. The next knob says wire speed, and it has the icon there. If you see the icon, it's got two circles with a line going through the middle. It's simulating that icon there. Those two circles, what are those things? Those are the two drive rollers, 1 and 2. See the wire coming through here between two drive rollers? That's what that icon means. So that's the universal sign for wire speed. Now with the wire speed, I would say, again, for the average stuff we're doing in here, it's usually between 2 and 3. So that's what we're doing, 2 and 3. Now, a couple more things with this. One is once you turn the machine on and you pull the trigger, you should see the drive rollers, you should see the wire coming out. As soon as this wire right here, as soon as this wire touches the table, it's going to light up. So be mindful that as you're getting stuff working and screwing around and pulling on the trigger and stuff like that, don't let this wire get too long. So the next thing I want to show you guys and this doesn't matter if you're doing Flux Core or MIG. This is really important here. This is before you even start. So before you start, you want to get your gun cable and you want to get it untangled. You want to get it untangled so that there's nothing on it. And so I'm going to pull it through. Okay, so with this cable, this gun, you do not want this thing wrapped up in a tight circle, okay? So you want this thing pretty free. Make sure that. Then this is what you want to do. You want to hold on to the wire and look at the circle. It should be expanding very smoothly, like that. So we just wasted some wire, but that's okay. Now watch this. If it looks like this, that's bad. So what that means, if it's not coming out smooth, again, this is smooth here. You've got to do this. So if it's not coming out smooth, what does that mean? Well, it could be that the tensioner here is not set right. So we might have to go like a half turn tighter there to put more tension between these drive rollers to grip it. So the way this tensioner works is we start off with it really loose and we pull the trigger, maybe you have a partner, and we just keep cranking this down half turn at a time until it feeds smoothly. If we didn't have this tensioner and we had this one, we just had an all or nothing deal. What would happen is that if the tensioner is too tight, if you ever dunk the welding tip into a weld and weld that tip shut, then it can't feed inside the gun anymore and it starts to bird's nest in here. The wire starts to come out of here and bird's nest. And so the tensioner, if it's adjusted correctly, these drive rollers will spin out on the wire. Okay? So imagine if you're in a race car, right? And you rev the engine really high and you pop that clutch. Well, your tires are just going to spin out for a long time on that pavement, burning rubber, right? So imagine these two drive rollers just spinning out. And let's see if it works right now. Let's do a little test. I'll show you this. Let's see if it's adjusted right. The camera up here. I'm using probably the cheapest tripod known to man, but we're going to get it to work. Okay, so will it bird's nest or not? Let's see here. All right, I'm going to simulate me dunking the tip by just putting my hand over it like this. So I'm going to stop the wire from going, okay? We're going to watch up here. See that? Those are spinning out. It did push this out a little bit, which we can fix. This thing, oh yeah, it's too loose. There we go. That should be tight. This knob holds this in. But yeah, it worked great. Spun out there, no bird's nest. And let's go ahead and loosen the tensioner so you can see this. Okay, here's my wire. Okay, I'm pulling the trigger right now. No good, right? No good. Half turn. Okay, it's better. Still not feeding very well. Half turn more. Pretty good. A little jerky. Half turn more. I like it. Done. Now, just so you know too, if you really want to be conservative, you know, you can pull the wire, you can undo the tensioner, and you can pull this wire back up to not waste it. I'm usually pretty lazy, but I gotta start doing that, I guess. But put the tensioner on and off. And don't forget, if it does bird's nest in here, or whatever happens, that spool runs out, you just pop off the tensioner, clip that wire right there, pull out the spool, put in a new one, or clear out the rat's nest, bird's nest here. You feed it, you feed the wire so that the wire comes right through here and goes right into this brassing. Once it gets in that brass thing, you know, 1/4 of an inch, that's all you need. Then you put the tensioner down and this up, and then from there, these drive rollers will push it all the way to the gun. But you want to be sure when you do that, that you have the gas nozzle out and the tip out. And sometimes it'll get stuck. The wire will come all the way through and get stuck right about there. And if that happens, we can kind of help it by getting this out. And we can help it. One second. All right. So you can see here, this thing's called the liner. And a lot of times the liner gets worn right here in the gun area. So what happens, a good practice most people do now is that they clip the liner right here, and then they have a separate liner going from basically this part of the gun, and they call that a jump liner. And they replace the jump liner much more often than they do the main gun liner. Whereas in the past, I was replacing the whole liner, but come to find out, it's better just to replace this section only. So anyways, get this on. All right. Also, we have to deal with the gas. And so don't forget that if you are MIG welding, especially, and you do not have the gas on, that your weld is going to suck. It's not going to be good. Your weld's going to be brown and look like a seagull was on it, like going to the bathroom. Not going to be pretty. So what you want to do is make sure that the gas tank is on, and when you pull the trigger, you take your knob here, and you have the bottom of the ball float. You know, we have no wind in this shop, so you could just go to 20, would be fine. But if there's any type of breeze or outside, you might be going 25. Flux Core is more around 30 to 50, but you know, at least 20. Again, you have to pull the trigger to have the bottom of the ball float at 20 or more. So let's let's take a look at our Flux Core machines, and some of you want to know about that. Any questions you guys have so far? All right. Now, let's say you're pretty good at MIG welding and you want to check out Flux Core. It's really easy, the dual shield. It's just the wire's 0.045, so it's 10 thousandths bigger than 035. Wire's almost the same. You got the flow meter, right? The polarity is the same. So it's really similar, you guys. So with Flux Core wire, you actually can break it by just moving it back a few times. Didn't need pliers, I just broke that off because it's hollow. So with the Flux Core, you know, the dual shield station works really good. Now, lastly, before we end this, what if you want to do the self-shielded Flux Core, also known as just, people say Flux Core. They mean self-shielded or inner shield. And this is the big time here, where you basically are going to be welding. You're not going to come into this booth unless you have quarter plate or thicker. So you're not going to be coming into this unless you have quarter plate or thicker. But the main mistake that students make is with the polarity. So remember that my ground plate cable here is going to go to positive. Ground cable goes to positive, and my wire feeder is going to negative. It's the opposite of MIG and dual shield. Other than that, it's really similar. The wire's way thicker here. You know, our guns, some of them are really, here, this one, let me show you this one. This gun here is, I mean, look at how long that goose egg is. Why is this so long? Man, when you're welding I-beams together, like half-inch stuff, like if your hand's this close, it's gonna get too hot too fast. So you have a pretty gnarly heat shield here. Pretty gnarly heat shield here for your hand, and you got it far away. So again, this is like the really thick metal, welding bridges together, pipelines, I-beams. So we got the exact same stuff that's used in industry. It's fun though. It's fun to go in there and give it a whirl. Yeah, so we'll go over more of the actual voltages, but still, you know, it's really still in there around, you know, 24 volts in that range. The wire speed we'll talk about a little more later, but that's kind of, I would say, that the things I'd like every student to know about our XMT 350s and our wire feeders. Like in a nutshell, I think if you guys, you know, review this video, you should be able to hook it up, no problem, hook it up the right way, and stick weld as well.